Hello, my name is Benjamin Ansel, and the topic I will be presenting on today is called MesoNet, a compact facial video forgery detection network. So during this presentation, three main topics will be focused on. First is the background of some of the techniques and architectures, which we will go through later. Secondly, we will go through the proposed method of dealing with the techniques used to tamper videos. And thirdly, we will have a code walkthrough of my Google Colab. Now, for the background, there is 4 questions which I question myself while researching on the topic. Firstly, what is deepfake? Deepfake is a technique that aims to replace the face of a targeted person with the face of someone else in a video. What is face-to-face? It's a reenactment method which is designed to transfer image, facial expressions from a source to a target person. Face-to-face is its most advanced form. It performs a photorealistic and markerless facial reenactment in real time from a simple RGB camera. Thirdly, what is Meso 4? This network begins with a sequence of 4 layers of successful convolutions and pooling, and is followed by a dense network with one hidden layer. To improve generalization, the convolutional layers use ReLU activation functions that introduce non-linearities and batch normalization to regularize their output and prevent the vanishing gradient effect. And the fully connected layers use dropout to regularize and improve their robustness. In total, there are 27,977 trainable parameters for this network. Lastly, what is Meso-inception for? It's an alternative structure consists in replacing the first 2 convolutional layers of Meso 4 by a variant of the inception module. The idea of the module is to stack the output of several convolutional layers with different kernel shapes and thus increase the function space in which the model is optimized. Moving on, we have some examples over here. Here is an example of deepfakes. As you can see, the top 4 images over here, these are the original images, and the bottom 4 images have been tampered with the deepfake technique. Next, we have an example of face-to-face. As you can see, the target image on the left here is combined with the source image on the right, which reenacts the image entirely, as you can see by the facial expressions. Next, just a brief overview of the 2 architectures. These are the 2 architectures of the Meso 4 and Meso Inception 4. Now we will discuss the proposed methods to deal with deepfakes or face-to-face. It turned out that these 2 problems cannot be efficiently solved with a unique network. However, thanks to the similar nature of the falsifications, identical network structures for both problems can yield good results. We will detect forged videos of faces by placing our method at a mesoscopic level of analysis. This can be achieved by using the following 2 architectures. First one, Meso 4, and secondly, Meso Inception 4. These 2 architectures was briefly explained in the background section earlier. Then now we will go through the steps taken while running the compact facial video forgery detection network. Firstly, face alignment and extraction. Secondly, extracting the data from the image. Thirdly, frame prediction using a deep neural network. And fourthly, we will predict the aggregation over time. Now we will have a code walkthrough of the Google Colab. So as you can see here, I have my Google Colab opened over here. We will just skim through all this and go to the code section. Okay, so first and foremost, to run the compact facial video forgery detection network, you would have to run the cells in the order they are presented. So first, we would have to clone the repository, as you can see over here. And then you would have to obtain the data from the Google Drive folder using these lines. Then we will have to import the libraries which are important for this method to work. And after that, we have three main code blocks. So the first code block is responsible to implement the architectures Meso 4 and Meso Inception 4. As you can see here, Meso 4 will be implemented here, and Meso Inception 4 will be implemented here. All right. So then the next code block would be responsible for finding the face from an image or video and predicting the images or videos of the faces. All right. And lastly, the third code block, which is over here, is responsible for detecting facial forgery. From the code below, we could change the directories of this to Meso 4 or Meso Inception 4. Both of these can be accessed from the Google Drive. And also we could change the directories or test images or videos over here, which can be obtained from the Google Drive also. And also we could also get a video from YouTube, for example, download it, and we can even run it here to test the detection network. All right. And the results can be seen as below here. So it gives a predicted and the real class over here. All right, now moving back on to the slides. So we just finished the code walkthrough from the Google Colab. And finally, in conclusion, these days, the dangers of face tampering in videos are widely recognized. We provide two possible network architectures to detect such forgeries efficiently. And with a low computational cost, this method shows that it has an average detection rate of 98% for deepfake videos and 95% for face-to-face videos under real conditions of diffusion on the internet. That will be all from me. Thank you.